Welcome to the channel. My name is Austin, and in this video we are going to control the speed of a 5 volts DC motor using a potentiometer. I'll show you how to wire this circuit in real life, how to program its operation, and then its real-world applications. To create our physical circuit, we need physical components. The first one is a 5 volts DC motor, which is an electrical device that converts electrical energy into mechanical energy. The second component is an L293D motor driver IC, which is an integrated circuit that allows us to control the speed and direction of two DC motors. But in this case, we shall only use it to control the speed of our DC motor. The third component is a 10 kilo ohm potentiometer, which is a variable resistor, and turning its knob clockwise or anti-clockwise changes its total resistance. And in this case, we shall use it as an analog input device to control the speed of our DC motor. The fourth component is a breadboard, which is a platform used to prototype circuits without soldering, and we shall use it to prototype our circuit. The fifth component is a bunch of jumper wires, which are basically conductors, and we shall use them to make connections between the different components of our circuit. Our sixth component is an Arduino microcontroller, which is an interface used to program the behavior of electronic circuits. In this case, we are using an Arduino Uno to program our circuit and also as a 5 volts power supply. But I highly encourage all of you to use an external battery ranging between 6 volts and 12 volts to power your circuit. This is because motors draw a lot of current. Finally, our seventh component is a data cable, which is used to connect the Arduino microcontroller to the computer. In this case, we shall use it to upload a program from the computer to the microcontroller to control the operation of our circuit. In this chapter, we are going to create our physical circuit. But before we do that, I would like to explain more about the L293D dual motor driver IC, which is an integrated circuit that enables us to control the speed and direction of two motors. But in this case, we want to use it to control the speed of only one DC motor. So let's learn more about it. So the L293D dual motor driver IC has 16 pins, 8 on the left hand side and 8 on the right hand side. To find its correct orientation, we use the notch at its center top. So in this case, according to the diagram here, the notch is symbolized by a semicircle, and this is what we use to identify its correct orientation. So according to its current orientation in this image, this would be pin 1, 2, 3, 4, 5, 6, 7, up to 8, which are these pins on the left hand side. And then pin 9 to 16 would be on this right hand side. So those are the pins, and that's how you find the orientation. But since we are interested in using it to control the speed of only one motor, we are going to use from pin 1 to 8 and then 16. The rest of the pins from 9 to 15, we are not using them for now because we are controlling the speed of only one motor. So let's go through the pins we are using. So the first one, which is pin 1, in this orientation, this would be the pin, this would be the pin 1. So pin 1 is enable 1 and 2. So we connect it to the 5 volts pin from the Arduino microcontroller, and then pin 2 is input 1, which is this pin here, and on this image it would be this pin. So we connect it to digital pin 9, as we shall use it to control the speed of the motor using pulse width modulation. So we connect it to digital pin 9. Moving on to pin 3, which is output 1. So output 1, we connect it to one of the terminals of the motor, either positive or the negative terminal. And then pin 4 and 5, which is this 4 and 5. 4 and 5, we connect them to ground, which is from the microcontroller. And then pin 6 is output 2, and we connect it to the second terminal of the motor, again either positive or negative. So depending on the connection you've made, it will just change the polarity of the motor. So your motor may either spin clockwise or anti-clockwise depending on your connection. So moving on to pin 7, which is input 2. So we just ground it, we connect it to GND from the microcontroller, and then the last pin on the left hand side, which is pin 8 VCC2 down here, which is this pin here. So this pin, we normally connect it to the external battery. We connect it to the positive terminal of the external battery, ranging between 6 volts and 12 volts to power the motors. But in this case, I'm going to connect it to the 5 volts pin from the Arduino. Although I highly encourage you to use an external battery to power your circuit. So if you have an external battery, you just connect the positive terminal to this VCC2, and then the negative terminal of your external battery, you connect it to GND from the microcontroller. So the microcontroller and the battery and the potentiometer, which we shall later add, you connect them, you make sure they have a common ground. And then the last pin we are using, which is pin 16, which is on the top right, which is VCC1. We connect it to the 5 volts pin, and this is the pin which powers the IC independently. So those are the connections we are going to make to control the speed of one DC motor. To create our physical circuit, we start by connecting the 5 volts pin from the Arduino to the positive rail of the breadboard. Then we connect the GND, which is ground from the Arduino, to the negative rail of the breadboard. And then we connect the L293D dual motor driver IC to the breadboard in a correct orientation. So let's start connecting the L293D dual motor driver IC. We start by connecting enable 1 and 2, which is pin 1 of the motor driver, to the 5 volts pin from the Arduino, which is the positive rail of the breadboard. We then connect input 1, which is pin 2 of the motor driver, to digital pin 9 on the Arduino. So digital pin 9 will be used to control the speed of the motor using pulse width modulation. We connect output 1, which is pin 3 on the motor driver, to one of the terminals of the 5 volts DC motor. Moving on, we connect pin 4 and 5, which is ground of the motor driver, to the negative rail of the breadboard, which is connected to the GND from the Arduino. We proceed to connect output 2, which is pin 6 of the motor driver, to the negative terminal of the 5 volts DC motor. Then we connect input 2, which is pin 7 on the motor driver, to the negative rail of the breadboard, which is connected to GND from the Arduino. Moving on, we connect VCC2, which is pin 8 on the motor driver, to the 5 volts power supply from the Arduino. Or you would connect the positive terminal of the external battery here on pin 8, and then you connect the negative terminal of the external battery to ground. Finally, we connect VCC1, which is pin 16 of the motor driver, to the positive rail of the breadboard, which is connected to the 5 volts pin from the Arduino. So this will be used to power the motor driver. So far, these are our connections. So let's start connecting our 10 kilo ohm potentiometer. We start by connecting the potentiometer on the breadboard in such a way that all its 3 pins are free. We connect the left pin of the potentiometer to the negative rail of the breadboard, which is connected to ground from the microcontroller. So your external battery, your potentiometer, and microcontroller all have a common ground. We then connect the right pin of the potentiometer to the positive rail of the breadboard. Finally, we connect the center pin of the potentiometer to analog pin S0 on the Arduino microcontroller. So this is our complete circuit, and we are going to connect it to the computer using a data cable and program its operation. In this chapter, we're using the Arduino IDE, which is the integrated development environment, to write a simple program to control the speed of our 5 volts DC motor. So here we have the void setup, which is where we shall write our code to run once. And then here we have the void loop, where we shall write our main code to run repeatedly. So we start by declaring and initializing variables. So our first variable is motor pin, and we initialize it to 9. This is because we connected the input 1 pin from the motor IC to digital pin 9 on the microcontroller. And then our second variable is port pin, and we initialize it to A0. This is because we connected the center pin from the potentiometer to analog pin A0. So that's it for the variables. Let's move on to the void loop, where we shall write code to run once. So here we are using a function pin mode, and we are going to set the motor pin as output. All right. So this helps the microcontroller to identify that we have connected an output device to digital pin 9, and digital pin 9 uses pulse width modulation because it has a squawk on it. So let's continue to the void loop, and this is where we're going to write our main code to run repeatedly. So we start by creating a variable val, which will store values from the potentiometer. So we equate it to analog read, open brackets, and put their port pin. Okay, so this function analog read is used to read values from input devices connected to the analog pins. So here, since we connected the potentiometer, which is an analog input device, to analog pin S0, we are using this function to read its values from there. And then this variable val is going to store the values read from the potentiometer. So let's move on. We then create another variable speed to store speed of the motor. So we're going to use this function map, and then we're going to map the values from the potentiometer from 0 to 1, 0 to 3, and then from 0 to 255. So this is just a range of values from the potentiometer, and then this is a range of values from 0 to 255. So this is just the analog way of saying from 0 to 5 volts. So all the values from 0 to 5 volts can be mapped. So this just scales values from the potentiometer to the motor. Our last line of code is analog write, then open brackets, motor pin speed. So this analog write is another function. It will send the instructions to the motor pin, which is connected to digital pin 9, to execute the speed according to this scale. So this will in turn control the speed of our DC motor. After writing the program, everything is clear. So we verify our program. Our program is working well and it has no issues. We'll just upload to the microcontroller. So let's test how it's working. In this chapter, we are looking at the real-world applications of our circuit. This circuit can be used to control the speed of a fan, can be used to control the speed of an electric scooter or bike, and it can also be applied in robotics. But to apply it in robotics, we'll have to replace the potentiometer with a sensor, such as an ultrasonic sensor, such that when the robot detects an obstacle ahead, it can gradually reduce its speed, and then when there is no obstacle, it can gradually increase its speed. So that's it for today. Thanks for watching. See you in the next one.